Welcome back to my YouTube channel. This video I want to explain about the oxidation numbers. We need to know what are oxidation numbers and how do we give the oxidation number for elements in the compound. Okay, so the oxidation numbers referring to these are numbers which represent the number of electrons which has been gained, which has been lost, or shared. So the number of electrons gained, the number of electrons lost, or perhaps shared. So oxidation numbers represent the number of electrons gained, the number of electrons lost, and the number of electrons which has been shared by an atom. Okay, so these are oxidation numbers. So the oxidation number, it can be zero, it can be negative, it can be positive. So it can be zero, it can be negative, it can be positive. So referring to the integers. So oxidation numbers are integers. Okay, so when the oxidation number is zero, simply means that the number of electrons assigned to this atom is equal to the number of electrons in each free state. That is when it is zero. Then when the oxidation number is negative, simply means that the number of electrons assigned to this atom is more than the number of electrons found in its free state when it is neutral. And when the number of electrons is positive, it simply means that the number of electrons assigned to this atom is less than the number of electrons in the in each free state when it is neutral. So this is about the negative, the zero, and the positive. Okay. Now we need to know some rules which are used. First, you look at the steps which are used when assigning, the electrons. The steps which are used when assigning the oxidation numbers to atoms. So the first step is you have to write the oxidation number for each non-atom below its symbol. So that's the first step. So write the oxidation number. Write the oxidation number for the non-atom. Okay, so for the non-atom. So write the oxidation number for the non-atom below its symbol, that is. So then from there, step 2, you multiply the oxidation number times the number of atoms present in that compound. So you multiply the oxidation number here. So multiply the oxidation number times the number of atoms. So times the number of atoms which are present in that particular compound. Okay, then now you have to, last step, you have to write the expression now, which will be equated to, the charge of that atom, the oxidation number of that molecule or compound, which is mostly equals to zero, but that's not the case for polyatomic ions. Okay, so you write now the expression for the element whose oxidation number is known plus the element whose oxidation number we are looking for is equals to the the oxidation number for that compound or molecule or polyatomic ion. Okay, these are the steps which I use. So here we'll just write an expression like that. Okay. Then now these are just the steps. Now we have some rules which you have to know when assigning oxidation numbers. The rules which you have to know, these are very, very important. The rules which you have to know when assigning oxidation number. Rule number 1. All elements which are uncombined has the oxidation number of 0. All uncombined element. So uncombined element has oxidation number 0. So has the oxidation number equals to 0. So the oxidation number for the element which are not combined, all those elements from the periodic table, as long as they are not combined with the other element, the oxidation number is 0. So if we talk about sodium, oxidation number is 0. Talk about magnesium, talk about oxygen gas, talk about hydrogen gas, As long as they have not combined with any other element, it means their oxidation number is equals to 0. Then rule number 2. Rule number 2, we talk about hydrogen. Hydrogen has the oxidation number of positive 1. Hydrogen has the oxidation number of positive 1. So the oxidation number for hydrogen is positive 1. There are some few exceptions for metal hydride when the oxidation number for hydrogen becomes negative 1. So this occurs in metal hydride. So this occurs in metal hydride. So in metal hydride, the oxidation number for hydrogen becomes negative 1. But in most cases, hydrogen has the oxidation number of positive 1. An example of a metal hydride is sodium hydride, like that. Okay. So here the oxidation number becomes negative 1. But in most cases, it is positive 1. The third rule, which we have to know, is about oxygen. Oxygen has the oxidation number of negative 2. Oxygen has the oxidation number of negative 2. Also has some exceptions, especially for peroxide. So in peroxide, oxygen has the oxidation number of negative 1. Oxygen has the oxidation number of negative 1. So in peroxide, that is. So we have to know these exceptions. Then rule number 4, you have to know about the metallic ion, the metallic element. The metallic element which are found in a compound always have a positive oxidation number. So in short, we're talking about metals. When metals forms a compound with the other element, especially non-metals, their oxidation number is always positive. Their oxidation number is always positive. So positive, like that. The sum of oxidation numbers for compound is always equals to 0, except for polyatomic ion. So 5, we're going to talk about the polyatomic ion. So when talking about polyatomic ion, we're referring to the ions which has 2 or more atoms combined. So for these, their charge will always be given. The oxidation number will be given in form of charge, whether positive charged ion or the negative charged ion. For instance, you can be given the carbon oxide, which is the C2O4 with a charge negative on top. So this is the oxidation number. So for this compound whose oxidation number is given, this is the oxidation number itself. But if they just write a molecule, like for example water, the oxidation number for this molecule is 0. When it is not indicated on top, it means this oxidation number is 0. So let's follow these rules to determine the oxidation numbers for different compounds, for different elements in different compounds. Okay, the marker is a bit sticky. It's giving me tough time to erase it off. Okay, so question 1, determine the oxidation number of carbon in carbon dioxide. We'll come back, we continue with oxidation numbers. Now we'll be looking at examples on how to calculate the oxidation numbers of certain elements from compounds. Okay, so the first example is calculate the oxidation number of carbon in carbon dioxide. So that's the first example. So we have calculate or determine the oxidation number of carbon in carbon dioxide. Okay, so how do we find the oxidation number of carbon in carbon dioxide? Okay, so what you're going to do is you write down the formula for carbon dioxide, CO2. Everybody knows that. Now we'll write the formula for carbon dioxide. The rules, remember the steps, you have to write the oxidation number for the non-element, and from the rules we know the oxidation number for oxygen. Now as we can see, we don't have any charge on top of this molecule, so which means the oxidation number for carbon dioxide is 0. So what we're going to do is, when you add the oxidation number of carbon plus the oxidation number of oxygen gas, it is giving us 0. Okay, let me just use oxygen. It is giving us 0. Okay, so oxidation number of oxygen from the rules which we learned earlier, it has -2. So -2. Now we have to multiply times how many atoms of oxygen do we have in this molecule? We have 2. Plus the oxidation number for carbon, and it is giving us 0. So we have carbon negative, positive is giving us a -4 is equals to 0. So this one is going there. And the oxidation number for carbon is equals to +4. Okay, so the second example is you have to calculate the oxidation number for sulfur, the oxidation number of sulfur in sulfuric acid. Find the oxidation number of sulfur in sulfuric acid. So what is the oxidation number of sulfur in sulfuric acid? So sulfuric acid, it is H2SO4. Okay, we have 3 elements now. The charge still remains 0. We don't have any oxidation number on top. So when you add the oxidation number for hydrogen plus, we have 2 hydrogen here, plus the oxidation number for oxygen, plus the oxidation number for of sulfur, then oxygen, it is giving us 0. Hydrogen, we said it has the oxidation number of +1. So +1 times 2, because we have 2 atoms of hydrogen in this molecule, plus the oxidation number for sulfur, plus the oxidation number for oxygen, which is -2, then times we have 4 of these here, and it is giving us 0. So we have, this is a +1. So we have +2 plus the sulfur plus, okay, it's giving us a negative, positive, negative, it's giving us a -8. Then it's giving us 0. So we put these two together, sulfur -8 plus 2, which is giving us 0. So sulfur, then the answer we're going to get there is -6 is equals to 0. The 6 is going the other side, and we have sulfur is equals to +6. So the oxidation number of sulfur in sulfuric acid is +6. Okay, then we look at another example about polyatomic ion instead of these molecules. Polyatomic ions, these are ions which has the charge already on top. So it can be positive, it can be negative. Okay, so let us calculate the oxidation number for manganese in permanganate. So that is example 3. So determine the oxidation number of manganese in permanganate ion. Permanganate ion. Okay, the formula for permanganate ion is the M for manganese, Mn, oxygen 4 with a charge negative there. So as you can see, the oxidation number of this molecule is negative. So we don't know the oxidation number of manganese, but we know that of oxygen. So when you add the oxidation number for manganese plus the oxidation number for oxygen, it is giving us -1 in this case. Okay, so we have manganese plus the oxidation number for oxygen, which is -2 multiplied by 4, because we have 4 of these here, is equals to -1. So manganese plus, okay, sorry, minus, so positive and negative is giving us a -8 is equals to -1. So the 8 is going there. So manganese is equals to -1 plus 8, which is giving us manganese is equals to +7. So the oxidation number is +7 for manganese in permanganate. The last example in today's video is finding the oxidation number of carbon in oxalate ion. Determine the oxidation number of carbon in oxalate ion. Okay, so determine the oxidation number of oxalate ion. So, oxidation number of carbon in the oxalate ion. What's the formula for the oxalate ion? The oxalate ion is C2O4 with a negative charge 2 on top. So it means the oxidation number for this ion is -2. Okay, so what we're going to do here, we have carbon 2 plus the oxygen 4, which is giving us -2. Okay, so what is we want the oxidation number for carbon, we know for oxygen, so we don't know for carbon, and we have two carbons here, so we are going to say 2 carbon plus the oxidation number for oxygen, which is -2 multiplied by 4 is equals to -2. Okay, so we have 2 carbon plus C, it is giving us a minus, so positive and negative is giving us a minus, and we are getting the -8, which is equals to -2. The 8 is going there. 2 carbon is equals to -2 plus C8, which will give us, I'll continue from here, which will give us C2 carbon is equals to +6. Okay, divide by 2, this one goes. The oxidation number for carbon in this case is equals to +3. So this is the oxidation number for carbon in oxalate ion. So this is how we deal with questions concerning oxidation numbers. If you have questions, you can leave questions in the comment section there. I'll be happy to reply to them. And please consider that we are offering online lessons in chemistry, physics, biology, and mathematics. So you can get in touch with us on 0972 36 50 11. You can call or WhatsApp that number. Thank you so much for watching. Bye bye.